Welcome back for the second video in lesson one. Okay, well, we're going to dive right into it. So what we're going to get into here is we're actually going to do some of the machining to this. So we're going to machine around this hex. We're going to machine this profile. We're going to machine this circle. We're going to machine this cross. And we're going to machine this slot. And then we're going to do the drilling. Okay, so we'll do two types of drilling. But anyway, let's get into this. So let's start with the top. Actually, check that. Let's start with the last surface we were on. So if we turn this toolpath on, that tells me right now that we were finished on the right side. So since we're oriented that way, we probably want to start there. That would make sense. There's no reason to flip the trunnion back up and start on the top. There's no advantage to that. Now, if there was an advantage to it, then I would do it. But let's go ahead and move forward with that. So I'm going to turn that toolpath off. And I'm going to make sure I am on the right side plane. I am. So you get my tool paths. And to do this one, I'm actually just going to do a dynamic mill. So one of the things I want you to recognize in here are the toolpath selection that I'm using. Not only should you be learning about how to do this with the 5-axis machine, but also you should be learning about these toolpaths as well. We'll be doing a lot of cool things with these toolpaths throughout these lessons. This is very basic for right now, but they will get deeper in and more advanced. So machining regions, we're going to pick that guy. Check. From outside, no, we want to stay inside of that machining region. We don't need anything in here. So go ahead and hit check. Tool. All right, so let's use... I'm going to be using a 1/4 inch end mill for most of this. So even though I could probably rough this out with a bigger end mill, I'm just going to use a 1/4 inch so I don't have to do a bunch of tool changes. So I'm just going to go in there and grab my 1/4 inch end mill. And in order to confirm, machine definition parameters, some of its tools have said change values, yada, yada, yada. Okay, so that's fine. It's just telling me here that this particular machine is not set up for 12,000. Its max spindle speed is 10,000. That's all it was letting me know there. I'm actually going to show you how to change that really quick. So I'm going to save this, and I'm going to go into machine, and I'm going to go into machine definition. Check. And I know the machine that I'm going to be using has a max spindle speed of 12,000. So what I'm going to do is go into the mill spindle group. I'm going to keep opening this up until I get to the VMC spindle, and I'm going to hit properties. And right here I have a max speed of 12,000. That's interesting. So this is actually set to 12,000. So I'm going to hit check. Okay. Next thing I'm going to go is the general machine parameters, and we're going to see what we got in here. See if I have anything in here that might be changing that. No, that's interesting. But generally speaking, this right here is where you change it. Minimum speed 0, 12,000. I'm going to make this 12,001 just to see what happens. And I'm going to go ahead and hit check, save that, and I'm going to exit out of there. Okay, and then I'm going to look at my toolpath, go back in here. I'm going to see if I can save the changes to 12,000 now. All right, now it takes it. Awesome. Okay, so my feed rate 0.001, or sorry, 0.001. Okay, radial chip thinning. Basically, what this does is it takes your surface footage and I don't want this at 12,000 either because this is steel, I believe. I think I said we were making this out of steel, so I'm kind of messing up here. So I'm going to set this to 400. And I'm going to set this to 1,000th chip per tooth, and I'm going to turn radial chip thinning on. Notice how the feed rate went up. Basically what this does is it takes your step over, which is set at 10% of the tool diameter. I'm going to change that to 20. And watch what happens. So this here's goofy too. So I have to change this to 650. I'll go in and change that then. But notice now it went down. So it's calculating it based off your step over, your feet per tooth, and your surface footage per minute. I always use this anytime I use dynamic milling. Let me hit check. Oh my goodness, this thing's gonna drive me nuts. And let's go to the machine, and I'm gonna go back into that machine definition. Check. I was just in here. I wish I had changed it. So I know that my axis feed limits are 833. And I'm going to go ahead and rotary axis is fine. Check. And I'm going to save that. Check. Yes. So it's just asking if I wanted to replace it with the updated values. Now I'm okay here. Now it's not going to freak out on me. I'm not going to leave any stock on the walls. Oh, really? Now it's doing it again? Not going to leave any stock on the walls. Finish pass. I'm going to take 1. No spindle override. Machine finish pass at final depth. Minimize burial. That's good. No spring passes. I don't really care about that. So depth. I'm going to select that. Looks good. Entry motion. We are going to helix in here. And everything there looks good. Check. Okay. There we go. Now I'm not wild about that retract right there. So we're going to take a look at that. Top of stocks right there. Feed plane. Well, that would be why. So we want 1.1, 1.25. Check. There we go. That's a little better. A little safer. Okay. That looks pretty good. Okay. So next thing I'm going to do, I'll go to the side, which is my back side. So go to levels, or sorry, planes, and we'll swap this to our CNT plane on the back. Okay. And for this, I'm actually going to do a contour. Basically because I have a vise here. We could technically, I guess, do this with a dynamic. I think I'm going to show you how to do it dynamic, actually. Contour would be really easy, and then we could just do multipass. But I'm going to show you how to do it with a dynamic. So the first thing I'm going to do is I'm going to go to levels, and I'm going to create a containment. And I'm just going to create a rectangle. And I'm going to make sure that it's big enough, but it's not quite touching that. Not quite touching that vise. Okay, I'm going to hit check. And I'm going to leave that on for now. And we're going to go into our tool paths, and we're going to pick dynamic mill. All right, my machining region, not going to pick that. I want the stock. Okay? I'm going to come from outside on this one because it's an external feature. My avoidance region is going to be that right there. Okay? And I'm going to hit check. And then my containment region is going to be this. And I'm also going to have some, well, I can't have air regions because I don't have the edges. So I'm going to hit tool, 1/4 inch. Sure. Everything looks good there. Depth. Make sure I got the depth selected correctly. That all looks good. Finish passes. I may have to turn that off. It doesn't like partial finish passes. So what I will do is I'll actually leave 0.005 on the walls, or maybe 10, 0.001, or 0.01. And okay, I'm gonna hit check, see what it does. All right, check that out. So now, when it comes in, We're not hitting. Just barely not hitting. It's engaging in the material. Because remember, there's material outside. You can see right there, it's engaging the material. And it's going to dynamically mill that away, which is an awesome path. So that's really how we're using our containment engineering. We're just saying, hey, I don't want the tool to go past that backside. I don't really care about this, so I just made it extra big. Next thing I'm going to do is I'm going to take a finish pass on this. So I'm just going to add a finish. And I'm just going to grab that to there. And check. Tool, 1/4 inch again. And, you know, as you probably noticed, I don't understand why this keeps defaulting to that. One of the other things, always change your plunge feed rate because it's going to drive you crazy. If I'm not coming in on the material, I make it really high. 2D, wear off to the left, stock to leave on wall 0. Okay, entry and exit. I do want an entry and exit, and I am going to adjust this contour. I'm going to make it maybe 0.01 longer. So I'm just going to actually type in a value rather than a percentage. And then I'm going to add my entry and exit here. And I'm going to leave it just the way you see it there, 10%, 10%. We'll see how that looks, and then I can adjust it accordingly if I need to. Linking parameters, depth is going to be right there. Top of stock. Oh, we got a call to voicemail. Top of stock will be right here. And feed plane will be 1.1, 1. Oh, these are all incremental. I'm messing up big time. Absolute, absolute. Okay. Messing up big time. I could have left them all in incremental, but oh, that one I'm actually typing in. 1.25. Okay. And we are good. I'm going to hit check. Okay. So my finish toolpath starts right there. And since I know that's not back further, I know I'm good. I know the tool's not going to collide because I already checked it with the dynamic, and it's actually in front of the dynamic. So that's finished. Okay. Next, I have this slot through here. All right. This is going to be on the left side of the part. So I'm going to make sure that my planes, my C&T plane are on the left. For this slot, I'm actually going to do a peel mill. So I'm going to click this off. I'm going to grab that to that. Ooh, yikes. Didn't like that. Undo. So we'll step this. And okay, hit check. All right, so I have my machining region, 1/4 inch end mill. Still don't know why this thing is defaulting to so fast. I must have picked it out of the aluminum or something. Let's make this 50. Radial chip thinning's on. Step over. We're only going to step over about 20% of the cutter here. And everything here looks good. Finish pass. Yeah, let's definitely finish that. We'll leave 0.005 on the walls to finish. Definitely climb and wear. That way I can adjust it on the fly. Depth. It's going to be to there. Top of stock is 1.0, I guess. Let's check. Nope, 0.95. 1.1, 1.25. And we should be good. Check. And there we are. So it's actually going to do that slot, and it's going to finish it for us. All right. Let's do this one. So this one, I'm going to dynamic mill. Come back, do a dynamic. I'm going to do my machining region, full check. Okay, stay inside of that. No avoidance rage, I don't need anything there. It's just going to machine everything out of that. 1/4 inch end mill. Once again, it's insanely fast. I don't really need to change this because this is going to be helixing anyway. Oh, what I did not do, I broke my own rule. You got to make sure that you set a holder. So, yes, let's go in and open the library. Let's go to our Cat 40 inch. I actually thought about this the first toolpath and I forgot to do it. Cat 40 inch. All these B's, that's for BT. That's a different tool holder. We don't want to use that. We want to go down till we get to the C's. Cat C4 is Cat 40. So we got a Cat 40, and this is an ER20, ER25, ER32. So Cat 40, the C3 is the length. So it's just a designation for the length. So you can see C4 is longer, 2.8, C3, C3. So let's do C3, 32, ER32, 2.575. So now let's do C4, ER32. You see now it's long. It's basically all but 4 inches. So it's like roughly a 4-inch gauge length. Okay, so I'm actually going to use an ER16 because this is a 1/4 inch tool. So that's perfect. That's a Cat 40 ER16 holder, and I'm going to have this extend. I'm going to have the tool sticking out of there, probably about 0.875. Okay, so that looks pretty good. The holder in this operation does match other holders specified. So basically, I want to update the assembly and use it for all of the tool paths using this tool. And that's what it defaults to, so I'm going to hit yes. That's what I want. Okay. We are going to leave no stock on the walls because this is a closed contour. So what we are going to do is we are going to actually put a finish pass on this. And I'll leave that on. That's all set. Good. Linking parameters. Oh, I am on the wrong plane. As you can see, I never changed my planes. So it's telling me the wrong depth and all that good stuff. Now, not to worry, I don't need to panic. I can come in here and I can change to my front plane. And these two, and then of course this one always stays on top. Now I can come back and set my linking parameters properly. Top of stock. 1.1, 1.25, all that's good. Entry motion helix, all that is good. I'm going to hit check. Oh, yikes. Okay. So this raises an interesting situation here. So notice how it did a profile ramp. So it's actually starting here and it's ramping down around that, as you can see. Now, it basically decided that it didn't have enough room for the helix entry, so it did a profile ramp, which is cool. That's intelligence in the toolpath. We don't want to plunge, that's for damn sure. So it automatically went to a profile ramp, which I'm okay with. Yeah, in this case, I'm good to run with that. I was initially kind of worried because I didn't see that, but now that I see there's a profile ramp, that's perfectly fine. All right, so let's save this. And let's go ahead and play all of this. So that looks pretty darn good. Now, I'm going to fast forward through all the facing operations. And now we're going to take a look at just this one. I'm going to slow this down. So helix is down. Working its way out. I always like to look at it from this view so I can make sure the tool's not going to hit the vise. And it's not. It's in the middle of that gap there. Also, just barely not hitting that voice. Goodness, look how close that is. Clearance is clearance. This is definitely not going to hit. I'm going to speed this up because this takes forever. It actually is pretty quick in the machine. This is one of those paths that takes forever to simulate, but actually really runs quick in the machine. Okay, all good. So everything there looks good. I'm happy with that. Okay, so let's get out of there. I am going to turn off my containment because I don't need to look at that anymore. And I'm going to come back in. I'm going to turn off all these tool paths. All right, so we have essentially a couple things left to do. Number one, we didn't deburr anything. So we probably want to chamfer some stuff or deburr some stuff. Number two, we need to drill those holes. So that's the next thing we're going to do. All right, so we're going to go ahead and drill using 3+2 in this case. So I'm a little aggravated because I actually recorded the second half of this video and my mic was off the whole time. So now I'm redoing it again. But anyway, let's get started. I'll show you how to drill these holes using 3+2, actually one hole. And we're going to pick the most extreme example here. So I'm going to pick this one. So we're not just drilling that on a regular plane. We need a custom plane for this. And the problem is it's very difficult to create a plane for a hole that's in at some random angle like this. So if we go to planes, we can't do from geometry because there's no geometry. We can't do from solid face because it's a curved surface, so it doesn't like that. We can't do from G view because we would never get it oriented correctly. G view means your graphics view. So if I created a plane right now, it's going to create it normal to the way I'm looking at it. We will use this later, so I will demonstrate that. From entity normal, I can't grab the bottom of the hole, so I can't do that one. Relative to WCS, can't use that one because it's not normal to any WCS planes. I could probably get dynamic to work, but it would be really painful. There's a lot easier way of doing this, and it gives us some geometry in the meantime. So I'm going to go ahead to levels. I'm going to create a new level. I'm going to call this hole geo. Okay, and I'm going to go to my model prep. And I'm going to grab hole axis. And throughout these lessons, we're going to learn a lot of unique ways and interesting different ways to create geometry that's needed for 5-axis machining. So this is going to be one of those ways. So I use this all the time. I'm going to pick the hole axis. I'm going to grab that hole. And it's automatically going to project geometry, a circle. It's going to give me an axis. It's going to give me a point. I don't really want the axis, so I'm going to turn that off. I don't know why it's even showing that, to be quite honest, because it is turned off. Probably from the last time I did it when I wasn't recording, or when I had my microphone on. So I'm going to go ahead and hit check. Oh, it showed it, but it didn't actually make it for us. Okay, cool. So there we go. So now we have a hole. We can drill that, but we need to create a plane on it first. So you may have guessed by the choices we looked at earlier. We're going to pick from geometry. I'm going to select that hole. Now, when I orient this, I'm going to go to top, and this is how I usually do it. Okay, so this is looking down from my spindle. This would be as if it was sitting in the UMC. I'm looking down from the spindle, my X positives to the right, my Y positives back. So I know that my UMC tilts and it rotates around the Y. That's how the B axis rotates. And I know my C axis rotates like this. So this would be the way it would look in the machine when it's machining it. So that's the one I'm going to pick. Now, if it wasn't right here, and it's surprising it's the first one, what you can do is just toggle through these, and it'll give you different orientations for your gnomon. All right, let me get back to where I was there. Okay, so that one's perfect. So I'm going to hit check. I'm going to call this hole plane. Check. Okay. That looks pretty good. So we're going to work on that. All right. Now, this hole is drilled in at an angle, a pretty steep angle, actually. We're not going to be able to just take a pointed drill and just drill down in there. We need to give ourselves a flat. So we probably need to like helix bore this or circle mill this first to give ourselves something for our drill to hit normal to, rather than trying to come down on an angle. That drill is just going to deflect. There are flat bottom drills that can handle stuff like this, but we're going to act as if we don't have any of those because normally we don't have any of those in our shop. I was doing hundreds of these parts, and I could find a drill that was flat bottom that would be able to drill. It actually worked. I would try one. I would use that because it would save an operation. But for now, we're going to do it the long and tedious way, we'll say. So I'm going to use a helix bore for this. I'm going to come in, grab that circle, hit check. Okay, I'm going to grab my 1/4 inch end mill. I'm not going to worry about speeds and feeds for this because you should know how to set those properly. We already have that set up. 0 stock on the walls, 0 on the floors. We're going to put this in wear so that way we can comp it at the machine in case it comes in a little small. We don't want our drill rubbing on the outsides of anything. We probably want it maybe just a hair big, but within tolerance. Roughing. I'm going to rough this. My pitch, that's the pitch that it helix down. Remember, I'm using a 1/4 inch end mill to rough out a 3/8 hole. So that thing's basically going to be almost plunging down at that pitch. So I need to reduce that because it's not going to be making a very big circle, but it's going to be going down very fast in that small circle. So I'm going to reduce that pretty significantly. I'm going to do finish. And normally I'll do a helix downward, but I'm just going to do a circle of this because there's probably not a lot on this. These feed rate overrides aren't necessary either. They should just be 100%, 100%. We shouldn't be making those any bigger. I'm not going to do a spring pass here. I could if I was really worried about the size or deflection of the tool. This stays in 3 axis because that's what we're doing. Remember, we've already created the plane, so our plane is going to control our tool axis now, or our tool vector. Okay, now we're going to set our depth. Okay, so this is where we're going to run into trouble. This solid is really a pain in the butt to select a depth. It just doesn't, it's automatically defaulting to the 0. So we need a piece of geometry down there. So we're going to hit check. And it's going to put it up there because I really selected depth. And we need to create a piece of geometry at the very bottom of that hole to select our depth. Now, there are a million ways, not a million, but there's a lot of ways we can create this geometry. I'm going to show you one. So this is going to be one of the unique ways you can create geometry. And I use this command quite a bit whenever I'm doing 5-axis programming. So what I'm going to do is I'm actually going to create a plane that intersects perfectly the middle of this hole. And if I look at this, if I go to my right side, my right plane is going to actually kind of intersect it. If this hole's in the center of the part, it would intersect it perfectly. So I'm going to come up and I'm going to go to relative to WCS. I'm going to pick my right plane. It's essentially going to make a copy of the right side plane. I'm going to call this hole geoplane because that's all I'm using it for. And I'm going to right click on it. I'm going to edit. And I'm going to grab the Z arrow and I'm going to drag it to the center. And you can see that hole is not in the center. It looked like it was, but it's not. You can never just assume things. You have to check. So now I have a plane that's exactly slicing down the center of that part. So what I'm going to do is I'm going to go back to my wireframe and I'm going to do curve slice by plane. And I'm going to try to just select the surface here. There we go. If I selected the whole part, it's not the end of the world, but it would just make the line all around the part. I really only want it on this surface. So I just got that face. And now I'm going to go in. We have a bunch of options here. We can do dynamic. Hold on. And we can do dynamic plane. I could have just did that. But I can also do name planes. And I'm going to go in and grab that whole geoplane, hit check. And it's going to create a piece of geometry straight down the middle of that part. One of the things I don't know if oh yeah, I did. There it is, whole geo. So all of our stuff's on whole geo right now, and that's where we want it. Okay. Now that I have that line endpoint, I can go select that and get my depth correct. So I'm going to go ahead and I'm going to select that. It still is going to give me a hard time. Well, I can get around that. Just go to my levels, turn off that solid. There we go. -375, which is ironically a round number. It's pretty cool that it worked out that way. Top of stock, that's just going to be the center of the hole. So that's 0. Absolute, and we'll make this absolute. So feed plane will be 100 thou above, and the retract plane will be a 1/4 inch above. And let me make sure we're in the right plane here. Whole plane, we are good. We need to change our offset to 0 to override it. I'm going to hit check. Check. And there we go. So let me turn the whole G. Actually, we'll leave that on. We still got to drill it. Let's go ahead and turn our solid back on. And let's go to our tool paths. Whoops. Let's go to our tool paths and select all. And let's simulate that and see and make sure that's in the right place now. I'll turn this up because we don't really want to see it actually doing it. Oh, it's perfect. It's exactly what we want. Okay. Now, there's one thing I want to address on this at the moment. If I zoom in here, you can see that my lead-in is an arc. Remember, I used where. So I cannot activate cutter comp on an arc. As soon as I put any amount of wear in my control, it's going to alarm out and say G41, G42, cutter comp activated on G2 or G3. So I need to fix that. And this is where I said I was going to come back to here. We need to enter at center and start and end at center. Sorry, start and end at center. And the entry-exit sweep needs to be changed to 90. And now I'm going to hit check. Now I have that lead in, that nice straight lead in. And you can see at the bottom I have nice straight lines for lead outs, lead ins and lead outs. Okay, so that will be fine now. All right, next we're ready to drill. So I'm going to go ahead and grab my drill, select that circle. I'm going to go ahead and hit check. Grab my tool, 3/8 drill. Keep in mind, I've already set this up. I set the holder up. I put it in ER16, Cat 40 ER16 with a 2.5 stick out. And we're going to stay in 3-axis because remember, we created a plane to control our tool. Depth. Just going to select the bottom of that hole. And we'll come back to tip comp here in a second. Top of stock. Essentially going to be 0. Now, is it going to be 0? That is the question. It's not, because technically we've already milled all of this away. So technically we could select down here if we wanted to. If I feel confident that that hole is just slightly bigger than the drill, and I want to wrap it down to there, I can. I'm probably not going to do that. I'm just going to go at 0, and I'll let it feed down through, and I'll be happy. If I was making thousands of these, I may change that. We'll make this 0.25. Okay, and we're in hole plane. Still everything 0. Check. Okay. So I'm going to turn off my whole geo. Come back on this level. Go back to my toolpaths. Select, and let's run it. Okay, that looks good. Our hole's drilled down in there. Now, are we sure that the depth is correct? No, we're not. Can we be sure that the depth is correct? Yes, we can. What we can do, and here's another little trick. If you don't know this already, what you can do is go into your planes, and we have this hole plane. I'm going to hit section view, section view. Uh-oh. Nope, wrong plane. Whole geo plane. There we are. Now it sections that part. So what I can do is I'll go back to my toolpaths, turn off my helix bore, leave this on, and we're just going to simulate this, and I'm going to go top. Oops, check that. Go back to my planes. Normal to that. There we go. So I put my G view, my graphics view on here. I'm going to hit check, step forward. Okay. Only the tip's going down to the bottom. Okay, so we need to fix that. Because even though I extruded this as a square bottom, technically I want that whole diameter all the way down to the bottom. So I will have a drill point in here, which is fine in this case. So I made this part, so I'm saying it's fine. So go to linking. I'm going to turn on my tip comp. I don't want to go 10 extra. I want to stop right at that. And I'm going to go ahead and hit check. And now I can simulate, and boom. Right there we are. It's exactly on that point. Check. And I'm good to go. Okay, so turn that off. Go into my planes. I'm going to toggle off my section view. And I go back top. All right, so that's going to be all for this video. The next video, I'm going to show you how to use a much easier way of drilling 5-axis. We're actually going to do 5-axis drill, which will allow us to grab the rest of the holes, do them all in one tool path, all different depths, everything. Super easy. Now, that does, well, I'll get to that when we get to it. I'm going to go into more detail than I need to. We'll also go into how to do the second side. So we'll set up our fixture for the bottom, and we'll finish up this part. So tune in for the next video, and let's finish this thing off.